Alright, first things first, start up the application. Got it there. Open a sample file that we're going to work on, which just happens to be the one I hand out free as a sample. What that does is takes the program and breaks it into two chunks. The procedure division statements over on the left-hand panel, and the variables that are defined in the program on the right-hand panel. Now, admittedly, the options are keeping only the variables that are in question in the list. So there's some of them that are hidden. We might deal with that later. I'm happy to go for a big screen because it makes it easier to see. The process that I expect people would use is to go through the program effectively from the start to determine what things are safely initialized so that they don't need to be dealt with in some other fashion, or determining that they don't need to be initialized because of the way they're actually used. The simple opener seems to be find those things that are initialized, mark them as valid, then go through the lists that have not been marked off as valid and see if they need any kind of special work. So that's what this guy wants to do. The valid quality is that lovely OK indicator. Some are ticked, indicating they are valid. There's no indication from the program code that they've been modified, or some that have been modified or been dealt with in a fashion that suggests they aren't pristine, those that don't have the tick. The reason the guys don't have the tick is annotated with a little one-character indicator thing. Some are really handy, like this M means that that variable was actually modified. There's a piece of code in the program that changes it. A U indicates that that variable was passed as a parameter, so the subroutine may well have changed it, which may mean that we need to change it in advance, or maybe it's suggesting that it's a received field that we don't need to change because it's going to be fully populated by the called routine. Another handy one is the P, indicating that this variable, which is at level 2, its parent was modified so that it might be in question as well. And lo and behold, in this example, the modification for the parent was through a call. C, whoa, this guy has a child that was modified, lo and behold, to indicate that it may well need some form of modification. Come see, come saw. What this application tries to make possible is a method of going through these variables and the program statements to tick off the things that are successful, leaving us with a list that we don't have confidence in. That then means you got some harder work. Okie dokie. How do we do it? My general approach would be to start with the program and see what in the front up bits actually are being dealt with. And you're going to see the obvious example of the perform initialization routine that sets certain things, initializes others, which is going to mean this initialize structure is obviously going to be safe because every time we enter it, we reinitialize it. Now, one handy way of getting around this program is to use the application to highlight those components, that item, so that we can see where it's used rather than trying to read it manually. The one method of doing that is to select from our list of variables an item in question. Here's one that's modified, so we just randomly pick it. Click, and over on the left we get some highlighting of the guy that was being requested. It's got some preceding and following occurrences. So if there were multiple of these, we'd be able to use the left-hand guy, which takes us to the preceding. I'll hit the first match, take us back to the first. Or we could hit the right-hand guy to take us to the next, which in this case there aren't any. One that does have multiple entries is this guy, as an example of what you'd see. This entry, to go back to the 0th entry, because he's entry 1, you'd hit the left. To go to the second entry, you'd hit that guy. Why not? Click. This guy happens to be the second entry. Screen is too big. Great. Going from the list of variables to the program statements is one method of navigating. Another, because we all need to have variations, is to use the actual components inside this program to do a search. The obvious example for me is this initialize. So we'll highlight initialization. Well, let's try that again. And hit it. The same highlighting gets done for this guy. Lo and behold, we go to number 2. Badoink, there's number 2. We've gotten here transaction index in this initialization section that's being done first up, because that's what was achieved here, the first perform. This transaction index is being set. So that, we'll double click it. Lo and behold, it gets highlighted over here as well. That guy is going to be safe. So we can mark him as happy. Click. Another item up there in initialization is initial structure. He's getting initialized, so he's going to be safe. He's going to be a happy fellow. So we'll click him. But watch, because you can see there's some children that got some modification qualities. Click. Do we want to change them all to be safe? Well, from the fact that it's an initialize in the startup section, the answer to that question is a yes. So we will mark it with a yes. Another interesting feature now is that that whole structure is going to be safe. Because of the option setting, the list of variables will no longer contain that structure. Click. It's gone from the list. You could bring it back just for the fun of it by removing the only in question variables, and there's our happy guy with all of the subordinates ticked. Rather than have to manually filter that out, turning that option or leaving it in the only in question allows this list to slowly get smaller as we make improvements in our knowledge of what's actually been done or not done. Back again to the initialize place, we've got redefining modified. Well, if every time we come in we touch on it, we must have a nice safe comfort level for that. It's a level 2, it is modified, we're going to click it. Lo and behold, the other in the entry is already safe, and the parent only is modified by a child. So we should see this guy disappear too. Wow, another disappear. The rest of the actual processes I know you're going to love and deal with. This one. I'm going to pretend that we learned by looking through everything else that it's a standard I/O area, like a program buffer, a file buffer. So it's not likely to need initialization. So given that's true, we'll hit the old yes. Do we want to percolate it down to the children? Sure, because we trust them. They're gone. That particular process of going through the list of variables to mark off those we feel confident are safe, to reduce the list by going either by selecting the variable in question and looking for it in the program, or by looking in the program to find it and then deal with the item in question, is what this tries to offer as a simple method. I'm not going to go any farther because I think you've got the idea, hopefully.